So the activity will start now. Please have your seats. Welcome back, everyone. Let's continue our journey. The ocean, beyond being a habitat for countless species, is also a surprising source of materials crucial for our transition to a sustainable world. Now, let's shift our attention to the fascinating role of biodegradable materials and the remarkable role that algae may play in transforming entire industries. Please join me in welcoming Mr. Li Han-kun, founder of KICCA Limited. Mr. Li will introduce us a future where packaging, plastics, and consumer products no longer pose a threat to our environment. Please welcome Mr. Li.
Good afternoon, everyone. It's a great honor to be in this very amazing blue ocean dome. And let me start with a question for you. Do you think algae is a plant? Is algae a plant? That's a question that I've been asked quite a lot. Maybe many of you will think it's a plant, but no, theoretically, algae is not a plant. And because they look green, but some of them behave like plants, and some of them behave more like bacteria, and some of them just don't fit in any category. But actually, they are not plants. They have their own category, so that's kind of cool. But anyway, what's important is not what algae are, but what they are capable of, and what they can do is really extraordinary. And my name is Li. I'm an engineer and researcher from China. For the past decade, I've been working at the intersection of environmental engineering and sustainable materials. And today, I'm here to talk about algae, something that I'm really passionate about. Algae is a very old organism in the Earth. They have been around on this planet for more than 1.6 billion years, long before dinosaurs, long before trees and grass and any other plants. And they grow incredibly fast, and they can absorb carbon dioxide more efficiently than many land plants. And best of all, many of them live in the sea. That means they don't compete with the land plants or land crops for freshwater or farming land. So when we are talking about carbon emissions, sustainability, or something that we are looking to capture the carbon dioxide, we're always thinking that algae could be a big part of the answer of that question. So let me walk you through a model that many of us in the research world have been talking about. That's using algae cultivation to capture and sequestrate the carbon dioxide. And this is how it works. Algae absorb carbon dioxide that dissolve in the seawater, and then the algae, through photosynthesis, with the help of sunlight, turn that carbon dioxide into biomass. And after that, we harvest that part of biomass for further use. Or if it's not harvested, this part of algae just sink to the seabed and sink to the deep sea, where they get locked away for a very long time. It sounds simple and elegant, right? But theories and models are one thing. What matters is, does it work in real world? So to answer that question, we joined a state-funded program that focuses on investigate the algae farming business along the eastern coast of China. And our goal is to take a closer look, not from the lab, but out in the sea. We want to build up mathematical models that can calculate the exact amount of carbon dioxide that can be absorbed by algae farming land. So what do we do? Imagine we set up some metering equipment underwater. It's like a cube, a virtual cube beneath the water. And we're metering the water on the virtual cube edge that to see how many carbon dioxide and other chemical compounds that flow through that virtual cube to see does it work for carbon capture. And here's what we found. An algae form do help capture carbon dioxide. The data shows that, the data confirm that. But here's the twist. We found that in some area, especially just near the seabed, higher than expected level of carbon dioxide and some organic compounds are over that area. So that's not supposed to happen. To answer that question, we dug deeper and we found that so many algae are left there to be sink to the sea. And instead of becoming carbon sink, they often corrupt before they reach the deeper level. So they release carbon dioxide and many other nutrients back to the sea. So that caused that higher than expected level of carbon dioxide. That's not what we want. So now we know algae farming do help carbon capture, but only if we harvest the algae on time. But the obvious question is, why do anyone don't harvest the algae on time? To answer that question, we talked to the local farmers, we followed the supply chain, and here's what we found. As you can see, this red stuff held in the farmer's hand was a type of red algae. After being harvested, most of this type of algae are used for feed abalone, and this is abalone on this video. Abalone is a kind of shellfish that very famous, very popular on dining table in many parts of Asia. I don't know if you have ever tried abalone. Okay, abalone, it tastes very delicious, and abalone farming is a very important industry in many parts of Asia, and of course on those regions we do that investigation. So here's the thing. Abalone grow very fast on cooler months, but slows down in summer and autumn due to their breeding cycle. So their appetite drops too. Meanwhile, algae keep growing, not that fast, not as fast, but fast enough to outpace the demand. So the price dropped very fast. And in some cases, the price dropped so low that it's not even worth harvesting. So imagine that spending time and effort growing something and only to find maybe it's cheaper to leave it in the water. That's many algae farmers have to face. That's the economic reality they have to face. So soon they left their algae in the algae farming or on the algae field and cut them off and let them sink. And soon the carbon we hope to capture or sequestrate just go back into the system. It's not just a problem in China. It's very common globally on this algae farming field. So like last year, FAO released a report indicates that the price of algae dropped so low and many farmers have to operate at a loss. Let's have a look at the current breakdown of how algae are used globally. And about 40% goes into animal feed, and 35% become human food, and only 15% goes into the industrial applications. That means most of the algae becoming food. And as food product, they don't need deep processing and do not generate high value. And so as food, they don't exactly quite essential compared to crops or meat and something we eat every day. So what do? We need to bridge the gap. We need to create more valuable applications for algae. Algae, they have a lot of names, they have thousands of species, but for so long, their value has been underestimated. They have a lot of species, they come into different shapes and sizes, but one thing, they all have in common. And every single algae cell is basically a tiny little chemical factory. And we can find in these cells with oils, fats, saccharides, many other valuable polymers. Now, I don't know if this will remind you something else, something that we extracted from the earth and turned that into fuel, plastics, fibers, and medicines, and even cosmetics. Do you know anything like this we extracted from the earth? Yes, that's crude oil. Crude oil is something, basically an ancient biomass. Million years ago, there are basically plants, animals, and of course algae. So maybe you will ask a question, can algae replace crude oil? That's a very big question. I won't claim we are there yet, but we've made some exciting progress. And here's an example. This is kind of saccharide that we find in algae. Exactly, it's in the algae shell. You can see the molecule structure tends to tangle together, which made this material weak and hard to be shaped. So often it was used to be a minor ingredient or some additive of other products. So they don't make a good use of it, I mean. And what comes to our mind that could we modify them in a way that help them to form some order bond that make them more useful, stronger, or more elastic. And with that properties, maybe we can do something more. And very exciting ideas comes across our mind. Maybe we can turn algae into plastics. We all know that plastic is a very big problem, a big environmental problem now. But the sad thing is we still can't live without it. And most of plastics is made from crude oil, and they are neither sustainable nor biodegradable. And recently some new fossil-based plastic was on the market, but either they are too expensive or come with very high carbon footprints. And at the end of the day, if it's made from crude oil, it's not truly biodegradable, right? So I think that's where our algae-based plastic comes in. We give it a try. At first, we made some like this. This is some algae hydrogel. We make hydrogel with algae, and it's quite soft. And the good thing is they do not cause any allergic reaction on human body. So it's very ideal for some medical applications, like wound recovery, or like ultrasound coupling gel, something like that. Yeah. But that's not the ultimate form we want. We want to make them more like a conventional plastic that can be used, can extend the commercial use. So we do more experiments on that. And finally, and eventually, and luckily we made some progress. We made some materials like this, some of the materials we made. As you can see, it's more like, it feels like, it works like commercial plastics. And the best thing is they are completely biodegradable. And the exciting part is by controlling the processing condition and mix in with different biofibers, we can get the materials in different properties and textures, as you can see, different textures, different properties. Yeah, like this one is more fragile, I think, and this one is more elastic, right? So with this method, we can produce algae-based plastic that are compatible with different applications. And on the way of developing algae technology, we are not alone. This is another example from a team from Qingdao University. They built some NFC chips with algae materials that open the door to combining electronic technology. So we want to explore our applications, and in different areas like disposal tableware. You can see this is a disposal tableware, and that is like a plastic bags. And this is like algae films, and what's more, that is 3D printable biomaterials. So what we want to offer is a new, sustainable, and carbon smart solution, a way to use algae to both capture carbon and at the same time reduce our dependence on fossil-based material. So, we want to help reshape the material supply chain. And that's how we create value and fight climate change at the same time. And ultimately, that's how algae can help save us. And let me end with one last thought. These days, when we talk about carbon dioxide, it's always the villain, a bad guy of climate change. But carbon dioxide itself is not the enemy. We human beings are the big bad guy. It's our unchecked growth, dependence on fossil fuel, and unbalanced system that accelerate climate change. Carbon itself, in all its form, is essential to life. And whether it's in soil, in water, or in the air, it's just a nature cycle. So what we need is not get rid of carbon dioxide, but to manage it better, bring it back to the balance, and leverage it in a smarter way. And that's the future we are working toward. And that's the future I hope we can pass on to the next generation. So that's all. Thank you for your time or interest. Thank you.
Thank you, Mr. Lee, for that energizing and forward-looking talk. It's exciting to see how material science, powered by nature, can offer us alternatives that are both elegant and environmentally friendly. Today has been incredibly fruitful, highlighting the many corporate initiatives and technologies already in place to protect our marine environment. To help us reflect on this insight and bring our summit to a close, I'm honored to welcome Daniel Yu, the director of Shero Initiative, to deliver the closing remarks for today's event. Please welcome Daniel.
Thank you. Hi everyone, I am Daniel. So, as we bring the summit to a close, again, I want to thank you all for your presence, your attentions, your participations. And this summit has not just been a series of presentations, it's been a platform for shared learning, for open dialogue. And most of all, it's the cross-border collaborations that really inspire us all. Together, we have explored urgent issues, promising innovations and real-world solutions that help us to shape the better world. Through the Obstacle SOS projects, we know that the obstacle shells can improve the water quality, increase the local biodiversity, and also help us to have oishi oyster. Am I getting it correct? Yes? 100%, right? So we also learned that the sustainability-focused media, like Hello ESG columns, has driven the new wave of sustainability awareness in China. And this afternoon, and thank you for Mr. Lee's excellent presentations, we know there is technology that we can find in nature that can reduce our plastic, our pollutions. So each of these sessions, while different in focus, share a common theme. Is that we just no longer imagine a sustainable ocean economy. We are actively building it and protecting it. What stood out the most over these last 2 days was not just the diversity of expertise, but the willingness to think differently, to act boldly. Science spurs business, and the local initiative inspire global thinking. And while the urgency of ocean degradation is undeniable, we also saw there's no shortage of talents, commitments, and creativity in the room. The challenge now is how we carry this energy, how we turn the idea and connection spark here in Blue Ocean Dome into momentum that lasts beyond today. Our speaker inside have not only informed us, but also inspire us to act boldly about what is possible. My gratitude goes to our co-host, Saraya, ZERI Japan, Formula Consulting, and the full team behind Shero Initiative. Thank you for your hard work and unwavering dedication in making this dream, our dream, happen. And of course, to everyone to participate here, thank you for your time, your attention, and openness to the idea. As we live today, I encourage each of us to think differently how we can continue momentum in our own work. Whether it's launching a pilot project, revisiting our organization goals, or collaborating with different stakeholders, or simply change the way we live everyday decisions. It all matters. So let's carry this sense of shared responsibility that has grounded this summit and stay in touch, supporting each other. Thank you once again for your attention and become part of this journey. Arigatou gozaimasu. Thank you.
Wow, thank you, Daniel, for your thoughtful and encouraging remarks. As we close out this two-day journey at the Sino-Japan Future Ocean Sustainability Trends and Practice Summit, I want to thank each of you, not just for attending, but for showing up with curiosity, commitment, and care. We've heard inspiring stories today, bold ideas and real-world solutions. More importantly, we've seen what's possible when people from different fields, cultures, and generations come together for a shared purpose. The work doesn't end here. In fact, it begins now, with each of us taking what we've learned and turning it into action, advocacy, and impact in our own circles. On behalf of all the organizers, thank you for being part of this important moment. Let's keep in touch, keep creating, and keep working for oceans that are clean, vibrant, and alive for generations to come. Until next time, take care and thank you.